Hi and welcome to my presentation about how to debug a container with a sidecar in Kubernetes using Gefyra. My name is Michael. I am a software engineer and co-founder at Blueshoe. Blueshoe is a Munich-based software development provider for cloud native software. We are creating a couple of tools and platforms, for instance, Unicube.io or Gefyra. And in my day-to-day business, I am advising our teams and our customers how to do cloud native development. If you want to reach me, then drop me a line at michael@unicube.io or find me on GitHub. And here is my agenda for today. So first of all, I'd like to introduce you to Gefyra and its project goals. Then I'd like to talk about my development infrastructure, my demo application, and how to debug the bug with Gefyra. In the end, I will wrap everything up. So let's get started. Gefyra is under development for a couple of months now. We have started it to give developers a completely new way of writing and testing their applications by using Kubernetes right from the beginning, and to make this as convenient as possible. So we'd like to promote more service-oriented thinking and to foster domain-driven mindsets. And we'd like to see the adoption of advanced Kubernetes patterns to become part of modern overall software architectures. Then generally speaking about using Kubernetes right from the beginning will increase the dev prod parity by an order of magnitude. So since you maybe already have members in your teams taking a lot of effort to describe Kubernetes environments for production or testing, why don't you take this work and bring it to your developers as well? In the past we have been working with telepresence 2 for quite some time, but we have been, at least our teams, a little bit dissatisfied with the features and the approaches, and couldn't find a good solution for us. So we set out and created Gefyra. One of the major project goals of Gefyra is to make use of conventional mechanisms and toolings that your developers are working nowadays already. So for instance, we'd like to support your favorite IDE, code hot reloading and mounting the current state of my source into the development container. You can override environment variables, drop into an interactive shell, and read the logs easily. And most importantly for this example is that you can attach a debugger quite easily to your application container instance, which is currently subject to your development work. Gefyra creates a dedicated Docker network on top of your local Docker host, and by employing a sidecar, which creates the underlying VPN connection to your Kubernetes cluster, your application behaves as it would run already within the context of a Kubernetes namespace. And that makes it very convenient for developers to write code that is for the execution already part of the Kubernetes cluster. So speaking about my example project here, I will bootstrap a local Kubernetes cluster using K3D. That means I have to do a couple of cluster configs, such as selecting the right Kubernetes version, set the correct port forwardings for HTTP traffic, and more importantly for Gefyra to work. I have dependencies which I am going to install using Helm charts and customize, and I will be providing a plain or a couple of plain YAML files to describe my custom backend application. And of course, developers are using kube control also during development time in order to interact with the Kubernetes cluster. So I need a Kubernetes cluster. As I said, it will be K3D. My demo application will perform or demonstrate an OAuth 2 login flow, or more precisely an OpenID connect flow. So I need some sort of identity provider. In my example, I will be using Keycloak. And for that to work, I need a custom realm with an OAuth 2 client for my backend service. I need, of course, a test user with the required privileges to log in. And I need the ingress configuration that supports that local, fully fledged OAuth 2 login flow for my demonstration. And on the other hand, of course, I need the workloads in order to run my demo backend application. And for this example, I will be employing the OAuth 2 proxy in a Kubernetes sidecar pattern. The backend application itself is made with Fast API. So this is a popular Python web framework. But this example, or better yet, this pattern is not specific to Python as a programming language. Rather, it's agnostic to the programming language that you are using. To set everything up, I will be using another tool that's created by our teams. It's called Getdeck, and it will set me up this environment in a second. I will just run deck get to this public repository, and I'm selecting the deck OAuth 2 demo. So this is all open source. It processes 5 sources of different kinds, such as Helm charts for the Keycloak, plain YAML in order to initialize Keycloak with realm and the user and everything, and of course my demo application as a backend. In addition, for this deck, there is the Kubernetes dashboard available, which is convenient for developers to watch all the services and pods and so coming up. The published ports are listed down below here. So my HTTP traffic will go on localhost port 8080. Wonderful. So what's inside of my example? I have at least 2 domains, local domains running in order to establish the OpenID connect flow. I have on the one hand the OAuth 2 demo domain. I am using nib.io here on port 8080 in order to serve my OAuth 2 demo, which is created with the sidecar pattern. That means that each and every request that comes through my ingress is then first authorized by the OAuth 2 proxy, and only authorized requests are passed through to my Python backend application. And that means that I separated my backend completely from the OAuth 2 login flow, which greatly increases at least the security, because I don't have to write custom code for the login mechanisms. And I'm using standard software here. And on the other hand, I have the Keycloak running on another domain. It's Keycloak on my localhost nib.io on port 8082. So just a quick recall how the OpenID connect flow is working. So if I want to access my backend application from my browser, I first have to request an authorization code. And this is done by a redirect from the OAuth 2 reverse proxy to the JSON Web Token issuer. And in this case, it's Keycloak. And upon providing my login credentials, I will be receiving the authorization code in a redirect. And it redirects me back to the OAuth 2 reverse proxy. And from there, my authorization code gets exchanged for a valid access token that will travel along in a HTTP header to my backend application. And having a closer look to the workload YAML that is creating the sidecar pattern, in the container section you can find 2 containers running in one pod. So there is the first is the OAuth 2 proxy, which is being served on port 8809, which is published through the Kubernetes service. And the second container is the OAuth 2 demo app. This one will be target for the Gefyra bridge operations in a couple of minutes. And this container is listening on port 8155, and the auth2 proxy is configured to upstream to that port. And this sidecar pattern is then rolled out with each replication of the deployment, meaning that for every pod that is scheduled by the auth2 demo deployment, exactly this pattern is part of each pod. And therefore, I'm not scaling just one component, for instance, my auth2 demo app, but rather I am scaling the auth2 proxy as well as my backend application. And this is pretty much what the sidecar patterns is useful for. So to see this in action, I will head over to my browser. And I pointed to auth2 demo on my local domain, just hitting the refresh button here. And the auth2 proxy welcomes me with this login screen. And it is configured to use OpenID Connect for the login flow. So I hit the sign in with OpenID Connect. And now please notice how I got redirected to Keycloak here. And I am now using my demo user. It's john@gefyra.dev. And the same is for the password. I hit the login. And here we go. I got redirected back to the auth2 demo domain, and the response for this simple example application is JSON telling me hello world. And this application allows me to, for instance, retrieve items. So I can go to the item route, items, and put items, and I put in 1, 2, 3 here, and it says, ooh, an internal server error. So this is the HTTP 500, a bug that is currently present in my current state of the application. And yeah, we already found the bug. Now we might take care about what is required with Gefyra in order to fix it. So this is the code that is serving the items route. And the first thing that comes to mind is, I think it's not a too uncommon anti-pattern to have an if-else branch that separates two environments. In this case, it is probing if a access token is available here, and if not, which is for a development environment which was not created using Kubernetes, and this pattern the token is not really used for creating the response. As you can see, the email is not given in this case. But once this application moves into a Kubernetes environment, employing the sidecar and also forwarding the access token, I'm hitting this nasty bug. So as an attentive audience, you might already spotted what's the problem here. I'd like to keep it open for a couple of seconds. Right, the process with Gefyra is quite simple. You run Gefyra up in order to set up the development environment and the infrastructure. You can then run Gefyra run within virtually any image that you'd like to run in a context of a Kubernetes namespace. Maybe it's a new service that is not yet reflected in Kubernetes workloads, but you would like to run and develop a new service in an existing mesh. You can run afterwards the bridge command, which intercepts an existing service and tunnels all the traffic hitting that particular container to your development instance. And in this case, you may write code, fix bugs, or write new features. Once you're done, you can commit and push, and the CI/CD pipeline will take over. And from a developer's perspective, you're now able to run the Gefyra down command in order to tear the development infrastructure down. So the Gefyra run command with this parameter list is doing the following. I specify the image. So this is basically the same image that is deployed to my Kubernetes cluster at the moment. I'd like to assign a name. It's my fast API demo for further reference. I want this container instance to run in the OAuth2 demo namespace, which is the namespace for my example application. And I'd like to mount my current working tree to this container. I am overriding the starter command here. I am using debug, which is a Python implementation for the debug adapter protocol. It is available for a long list of programming languages too. So the debug is waiting for a debug client to connect, in this case on port 5678. And then I am starting UVcorn, it's my application server. And this is basically the same command that the application is also started in Kubernetes at the moment, except for the reload flag at the end, which allows me to reload the application upon changing my source code. I will head over to VS Code to demonstrate how this looks. So first I have to run the Gefyra up command. It installs Gefyra's operator to my local Kubernetes cluster, does everything else which is required for my local development infrastructure. I have the code which is currently serving the server error already at hand here. And I will be running a development instance of this application container in a second. So Gefyra is up and ready. So I am running this command. Okay, this container has been started locally. I can inspect the Docker PS with my fast API running locally here. So and now for VS Code to connect to the debugger, I'm going to create a launch JSON. We'll do this with the debug extension, create a launch JSON, and select the remote attach in order to connect to a remote Python debug server. And it asks me about the host name. And in order to find out the IP address of my local container, I am running the docker inspect command, and it tells me the IP address. By the way, this will be part of Gefyra in one of the upcoming releases to make this even more easy. So I put the IP address in here, it's the default port, and I hit enter, and VS Code creates a launch JSON. And now by starting the debug, I am getting connected to my local container instance, and it already tells me that UVcorn is running on this container address, and it basically started the application already. Wonderful. Now getting back to my slides, because now I have started the container instance running in my Gefyra context, and it is running as part of the Kubernetes namespace in my application landscape. So in order to receive requests, I have to create the Gefyra bridge. And this command is going to do that. It's a bridge, and on the one end of the bridge, I target my fast API demo, the local container instance that I just created. And on the other end, there will be everything scheduled by the Kubernetes deployment OAuth2 demo. So this deployment is placed in the namespace OAuth2 demo. And I'm particularly interested in all containers within pods that are named OAuth2 demo app. You remember it's the second container in my sidecar pattern, which runs on port 8155. So this is the same that I'd like to forward to my local container instance. And I assign the name my fast API at this point, again, for further reference. So getting back to VS Code, I will change to the terminal again, clear my terminal, and run the Gefyra bridge command. And it selects one pod with this name. Gefyra is now waiting for the bridge to become active. And once a connection is established, my local container instance is now serving the requests for the OAuth2 domain. I can demonstrate this if I go back to the browser. And here I can go, for instance, back to the front page, and I get the already working Hello World response. So if I get to the items /123, it's still the internal server error, of course, because I did not change any code so far. So getting back to VS Code and changing to my code that is being executed, I can now drop a breakpoint at this position in order to interrupt the execution and to find out what's wrong with this code. So if I now start a new request on that particular route, it is interrupted and VS Code already popped up with the breakpoint being halted the execution. And I'm now able to inspect the data, which is the JSON Web Token decoded. And I am now able to inspect the keys of the web token. You can see it's just an ordinary JSON Web Token, nothing special here, but it tells me the email key is actually written with a lower e in the beginning. And if I go on with this run, I'm even able to head to the output of the application. And here it tells me about the key error too. So now I can change this uppercase E to a lowercase e and remove the breakpoint. And since I activated the reload flag in my application server, I will be reloading the code, and now my application is executing my changed code. I hit the refresh, and it still says internal server error. And this is because I forgot to save the source file. Okay, here we go. So this response is now working, and I fixed the bug. Wonderful. Yeah, basically that's it. Back to my slides. As I said, in order to fix this bug, I had to make the uppercase email to a lowercase email because this key access caused an exception. That's it. I have demonstrated that Gefyra is able to create a Kubernetes-native development approach by creating a local container instance with all conventional capabilities for developers writing their code, being executed at the same time already within a Kubernetes context and just side by side with existing adjacent services. So there's no need anymore for a Docker Compose or Vagrant setup or any custom scripts that create a development infrastructure which is not really matching your production systems. If you want to follow along this example, please head over to gefyra.dev/usecases/auth2demo. And if you're interested in using getDeck, I would be happy to see you in this repository too. So if you do have any question, then please reach out. And in any case, have a wonderful day.